Hello, in this lecture we're going to continue with our discussion of production and cost analysis, chapter 11. Remember that our goals are to explain the role of the firm in economic analysis. We've discussed that, describe the production process in the short run, calculate fixed cost, variable cost, marginal cost, total cost, average fixed cost, average variable cost, and average total cost. We'll start to get into this at this time, distinguish the variable cost curve, and describe the relationship among them. Okay, so we have the production table and production functions. So firms combine factors of production to produce goods and services. So obviously we're going to take the factors of production, combine them, produce goods and services. So a production table is a table showing the output resultant from various combinations of factors of production or inputs. So if we take a look at the production table in the real world, tables can be quite complex. We can take in a lot of factors within the production table. This analysis will concentrate on a short-run production in which one of the factors is fixed. So let's take a look at an example here. We've got one fixed factor. Look at our table. We have a nice Excel sheet here, of course, which is very nice. We're going to start off with the number of workers. So if we think about this, we're just going to take the numbers of workers. We're going to go up from 0 to 10. So we're going to just take one worker at a time. We're going to analyze as the workers go up what happens to output. So we're going to compare the workers increasing and then the reaction to the output on the workers increasing. Then we'll calculate the marginal product. So remember, when we're thinking about economics, we're always thinking about things on the margin because we want to think about what the next decision will do. We're going to think about the marginal cost and the marginal benefits. In this case, we're going to think about the marginal product, and we'll calculate that as we'll go. I'll show you how to do that. And then we'll take a look at the average product. So let's just think about this table. If we start at 0, then of course the output's going to be 0. If we make something like hamburgers or something, then we have 0 workers, we make 0 hamburgers, and there's no average because we haven't made anything. If we have 1 worker, so we go from 0 workers, we hire 1 worker to run our whole hamburger place, then we have 1 worker, and we're going to say the output is 4. Where did the 4 come from? That's just part of the table. They're saying that if we get 1 worker, we're going to have 4 hamburgers or output that will happen. And then if we think about the marginal product, then what happened is we're going to take the increase in the output, in this case, 4, 0 minus 4, 4 minus 0, and divide that by the change in workers, in this case, the input, which is 1 minus 0, just 1. Therefore, the marginal product is 4. So we have 4 is the change. If we were to take our average, then the average is just going to be the number of burgers made, 4 divided by 1. So our average, of course, now is just 4 at this time. So we're going to say, that's great. We got this 1 person handling our whole burger shop. Let's hire 2. Let's hire another one. And so now we have 2. And we're just going to say that now they can produce 10 burgers. What did we come up with that number? That's just the number that we are predicting that can be happen or that did happen depending on how we're analyzing this data. So what does that mean then? In terms of the marginal product, it means that 10 minus 4, so the new area that we're out in output, 10 burgers minus the prior 4 burgers, divided by the change in workers, which is 1, means we have a change of 6. So the next individual brought in 6 more burgers. So not only did that go up, but it went up at an increasing rate. The first person was only able to produce 4 burgers, and the second person was able to produce an added 6 burgers. And at some point at the very beginning of production, when we just hire workers, we kind of expect that to happen. And why would that happen? Because if you just hire 1 person and they're running the whole store and they're kind of doing the burgers but they kind of have to do other stuff with customer service and other things, then it would make sense that the second person might allow for increased rate of burger production. If we take the average, then of course now the average is going to be brought up by the fact that we have now brought in a marginal product greater than the prior average. Therefore, the average is now going to be the 10 divided by the 2, which is 5. All right, so then what's doing great? Well, we're going to hire another one then because this is going good. So we're going to have another one. Now we have 3 workers, and we're going to say that they produce 17 burgers now. So what's the marginal product? Well, we're going to take the 17 minus where we were at last time, and that means we have 7. So there's a change in 7. And of course, you could divide that by the change in the input, which is 1. So we just have 7 over 1, which is 7. So we have the 7. And once again, we're going to say that there was an increase in rate of return. The last person on the margin we brought in 6 more burgers. we brought in another worker and production went up by 7. So the on the margin went up higher than the prior. And that, of course, will bring up the average then. So if we take the average, 17 divided by 3 burgers, we are now at 5.7, up from 5 last time. So it's still going great, so we're going to hire another one. So now we're at 4. And so 4, and we're going to say that we get 23 burgers when we have 4 workers. And so once again, if we take the 23 minus where we were at last time, 17, then we have an increase of 6. So obviously 6 again over the 1. So an increase of 6. Now that's an increase, that's good, but it's not as good as the prior person. And so we have an increase at a decreasing rate at this point. So we're still going up, but we went up at a decreasing rate. And we might ask, well, why would that happen? Is it that this worker is worse than the last worker? And of course, we're going to say, no, this is a theoretical table where all workers are the same. We still expect there to be a point at which there's diminishing returns. And of course, if you think of the idea of the one worker going in and they have so much more work that they can basically handle, if you have another worker going in, it may just be that there's not as much work that they can take over that would be as productive as the prior one. And that will happen at some point generally in most areas. We do see that this 6 is greater than the average last time, so we would think that will increase the average. So if we take the average of the 23 divided by the 4, we are now at an average production of burgers for our 4 people of 5.8. Then we're still going up, so we're going to hire another one here. So we're going to hire another one. Now we're producing 28 hamburgers, and that means that if we take the 28 where we're at now minus the 23, the new person that we brought in now has 5. So they produce 5 more burgers. Once again, it's an increasing number of burgers overall, but at a decreasing rate because the last person brought in 6. Now we're bringing in 5. Again, we kind of expect that to happen. Notice that this 5 is less than the average. So now when we calculate the average, it's going to be bringing the average down now as well. So if we take the 28 divided by the 5 workers, we got the 5.6. And we're still going to hire another one. So we got another worker. Now we're making 31 burgers. And once again, if we take the 31 minus the 28, there's a change. That new person increased production by only 3 burgers. And once again, that's below the average last time. So our average is going to be dropped down. So we got the 31 divided by the 6 gives us the new average of 5.2. And at this point, we might want to stop, but we're just going to keep going and for purposes of analysis here. So we have 7, another worker bringed in, and now we have 32 burgers. And if we take the 32 minus the 1, we have a marginal product. We only brought in 1 more burger by hiring that individual. And that, of course, brings the average down of 32 divided by 7 to this 4.6. And for some reason, we're hiring another one. We're going to say, okay, let's bring in 1 more. We have 8 workers, still only producing 32. So we brought in another worker, didn't make 1 more single burger, and that means we're still at 0. And therefore, that's going to bring the average down. We got 32 divided by 8 now, so now we're at 4. And for some reason, we thought we'd hire another one, even though we didn't get any more burgers after the last one. And so we're going to say, okay, this probably wouldn't happen in real life, but now we're going to have 9 in people. And we're going to say that now they only produced 30. Therefore, the 30 minus the 2 is a negative 2, which of course definitely brings down the average. 30 divided by 9 is 3.3. And we might say, well, would this happen? And theoretically, we think that, yeah, it would happen at some point. You can have too many people in the kitchen and they can't make any more burgers at some point. There's just so much, individuals can do. They're actually going to get in each other's way. Hopefully we stop hiring before that happens. But we do think that theoretically there would be a point where actually more workers are less productive. And then if we did it one more time, of course, same thing. We went up to 10. Now we're only producing 25. We have a loss of 5. So that's not good. So now we're down to 2.5. If we saw this graphically, the graphic would look something like this. So we've got the Q quantity on the vertical. We've got the number of workers on the horizontal in this case. And then here we have our graph. So we bring in the 1 worker, the 2 worker, the 3 worker, and we note the areas in our graph. And this area we have increasing returns. And you can't see it too much in this graph, but notice this one's, it's going to kind of like bow upwards, meaning it's going up at an increasing rate, as we saw last time, meaning every new person is bringing in more burgers than the last person. Every new person we bring in is not only increasing the overall number of the burgers, but they're increasing the overall number at an increasing rate. The new person is making more increase in burger than the last person. And then, of course, at some point, that's not gonna last forever. Most of the time, we're somewhere in this area of diminishing returns. We're trying to decide if we want to hire someone else. We know that if we hire someone else, it's not really possible if they're at the same skill level to increase the production as much as the prior person, just because of the nature of the production process. So we're still increasing, but we're increasing now at a decreasing rate, meaning the new person is increasing to our total production. However, they're doing it at a decreasing rate, meaning the person before them had a marginal increase greater than the marginal increase of the next person. We expect that to happen, and a good firm should expect that to happen at some point. We shouldn't say, hey, this worker, we just brought them in and they didn't bring up our marginal product as much as the prior worker. What we need to consider, of course, is that their fault, or is that how the company works? Should that have been expected? And then at some point, we shouldn't hit this point, hopefully, but then we're going to have some point where it actually tops off and we're not having any increase in production, meaning we're bringing in someone else and that they're not bringing anything new in, and even start to drop off production. And of course, theoretically, we know that's going to happen at some point because you can have too many people in the kitchen. It's even a phrase. So it's going to happen, but of course, we don't want to get to that point. And if there's a change in the level of production or other changes, we could consider whether we're at some point like that as well. So now we're going to graph the marginal and average productivity. And this could be a little confusing when we start to calculate the averages. Note what we have here is we've got the quantity on the vertical, we've got the number of workers on the horizontal. And so what we're trying to calculate in terms of the marginal product is we're trying to say how much more production after each individual is brought in. So notice that's going to be the average between the two. So when we went from 0 to 1, that means that there was a margin of the 4 if we go in between them. And then it went up. When we went from 1 to 2, we said that the margin in here was 6, meaning it went that individual brought in 6, whereas the last individual brought in 4. We have an increasing marginal product. And then, of course, when we go from 2 to 3, then we had the marginal product of 7, and that's where we topped off. This should top off at 7, and then we had decreasing returns after that point. So at every point after that, then we had diminishing marginal productivity, meaning the next individual was still adding to the total, but it was going down in relation to the person before them. And then, of course, when we get all the way over here, we're saying now the next person is actually bringing in negative. So the next person is actually decreasing the number of burgers that we have. If we think of that compared to the average, then remember what the average is. We're going to take the total output and we're going to divide that by the number of workers. And of course, as the marginal product goes up, that's going to bring up the average, because the next individual's bringing in more than the prior individual. And as long as the marginal product is greater than the average, then that, of course, will bring up the average. Notice we're going up as long as the marginal product is greater than the average, because that means that every time a new worker comes in, they're bringing in more burgers than we were averaging before, which is going to bring up the average. So if we think about that in a grades terms, as long as the next grade we get is greater than our average grade, then that's going to increase our GPA. If we have our cumulative GPA in our next of 3.0 and our next grade is anything above a 3.0, that's going to increase our cumulative GPA. But then, of course, once our marginal product dips below the average, so if we had a cumulative GPA of 3.0 and then we got a 2.5, now we're on the margin, the next one is below our average. That's, of course, going to bring down our average. So then, of course, our average goes down as long as the marginal product is below the average graphically here. All right, so if we think about this in terms of our graph again, if we bring this graph back to our table, then we know that a law of diminishing marginal productivity states that as more of a variable input is added to an existing fixed output, after some point the additional output from the additional input will fall. So that means, remember, we have increasing returns here. Same thing we saw on the graph. And then we have diminishing returns here, meaning it's still going up. Our output is still going up, but it's going up at a diminishing rate, at a decreasing rate. And then, of course, down here we have diminishing absolute productivity, the new person actually brings in less burgers. We don't want that.